everybody. I think there is a, okay, fine, everything is up. Hello, everybody. Welcome to the talk. I'll just start with a simple quote. Languages are built for a purpose, and every language out there is built for a purpose. For example, you have Rust. Rust is built for thread and memory safety, and Go for concurrency. Use them wisely, and choose a language that doesn't create a problem for you, and that solves a problem that you have. With that said, welcome to State of WebAssembly. How many of you have used WebAssembly before here? Used? Oh, a couple of hands. Good. Great. So I'm Sendil. I'm currently hacking on WebAssembly on my free time, and I'm part of Rust and WebAssembly working group. And the main motto of the working group is like to make Rust and WebAssembly to work together. And my main role over there is like enable JavaScript developers to do Rust and WebAssembly, and that's basically it. How many of you agree with that? Oh, OK, quite a few people. Nobody throwing stones at me. That's great. Yeah, JavaScript is weird, and it's a JavaScript conference. I do understand. But you have seen a bunch of different questions, right, in the round that we had in Kahoot. JavaScript is actually weird. What do you think is the answer for this one? Any hands? Anybody saying not a number? A string? Anybody? I know it's the last session. Just cheer up. It'll be great. Hopefully. What do you think is the answer for this? Object, object? 10? Wow, that's a good guess. The answer is actually this. Why do you think this happens? Because when JavaScript sees an add operation, what it does is like it converts that into primitive. And the only way to convert an array into primitive is doing a .toString. And that's how it happens. Now, you agreed, right? JavaScript is weird. Well, sometimes. Every language out there is weird. So JavaScript is also weird. And the other weird part of JavaScript is JavaScript execution. And all of you are JavaScript developers, right? Any non-JavaScript developers here? OK, everybody. And everybody knows how JavaScript works inside your browser or a JavaScript engine, right? Can I assume that? OK. So you're going to load your JavaScript. That's it. Once you load, the first thing that happens is like it kind of downloads this entire JavaScript file that you've added. And once it is downloaded, it parses that into an abstract syntax tree. And this abstract syntax tree is then interpreted, converted to bytecode, and that is executed. Because JavaScript is an interpreted language, right? Everybody agrees? Yeah, great. But there is this guy who's sitting inside your JavaScript engine, which is called as profiler, and so some browsing engines call them in a different way. But this profiler sits there and watches the execution, and sees which functions is getting called more and more times, and marks those functions. And what it does is like it tries to compile them. Once it compiles, then it tries to optimize the bytecode that is generated, and then it goes and executes. But what the compilation and optimization here is like JavaScript makes some assumptions, the engine makes some assumptions, and then runs those assumptions. And there are certain browsers which does it like 2 times. Some browsers does it for 3, and some browsers is doing it for 16 or 15 times. And basically what they try to do is like they put on more and more assumptions to make the system more faster. And finally, everything is garbage collected. That's how JavaScript engine works. Great. And you will do this tuning, right? How many of you have done JavaScript tuning? Few hands. It's a painful process, right? So tuning a particular function, going through the flame graph, and then finding out which function is calling longer time. It's very painful, one. And there are like multiple different browsers, and all those browsers have like 3 or 4 different JavaScript engines, and everything is built in a different way, which means the performance differs between them. How many of you have done this? CSS tuning. Anybody? Few? Like it? WebAssembly will not help you here. But again, JavaScript is weird, but it's awesome, because 90% of users love developing JavaScript. And that is a huge number to have, right? And it's easy. And that's the main reason why you're seeing it to be at top for 6 years in a row in GitHub profile, GitHub most used languages, because it's very easy. And it's also evolving, and people are quite OK with the evolution of JavaScript, and that is the biggest strong point for JavaScript. Like 2 years before, we started complaining like there are hundreds of libraries, billions of libraries coming outside, and it's very difficult to track them. But now people are OK with it. Like 40% of people are happy in the direction it is going. That's great. So what is the problem with JavaScript, basically? first and foremost problem is types. Without types, JavaScript is lexically and syntactically very easy to write. But without types, you're pushing the problem to the compiler. Now, it's easy for you to write, but the compiler does all the hard work. And when it's doing that hard work, sometimes it has to take a guess. And whenever it guesses, it says like, OK, that person is a polymorphic stuff, or that thing is a polymorphic thing. So this guesses, what it does is like, it gives you an unpredictable performance. And that is a problem that we are facing. And finally, all those things combine together to give you runtime exceptions. Anybody here loves runtime exception? OK. So that is the biggest problem that we have inside this JavaScript execution or inside the JavaScript world. And this holds true because people are trying to solve this typing information. And like 66% of users are interested to know more in TypeScript. And if you go back and see the GitHub top languages used report, TypeScript is actually in top 7th position, and which is a subset or superset of a language. And that is growing up and up just because people want to add in a type information to it. And the main problem here is people are not fixing that typing information inside the JavaScript engine. They are fixing it way before it. And sometimes it helps, but TypeScript also has an any type. And if you put the any type, you need not use in TypeScript. You just go with JavaScript, right? So that is a problem that we have, types and unpredictable performance. What if we have a system that is typed and gives you a predictable performance? That would be awesome, right? And that is WebAssembly. That is all about WebAssembly. Do you fear that? Anybody fearing this? No, it is not a front-end framework. And basically, you have this JavaScript file, which runs inside your JavaScript engine. And then you have this native code. For a long time, we want to run this native code inside its runtime. Native code actually runs inside the runtime. For a long time, we wanted to run this entire thing inside or along the JavaScript stuff. And that is what we have done so far. And those are the results. Flash and applets. Anybody still developing Flash for IE6? OK. You're having good life. Great. But again, the JavaScript and JavaScript engine, and then you have this native code. What if there is a way in which I convert this into binary code and run it inside the JavaScript engine itself? That is WebAssembly. And WebAssembly is not a language. It's a high-level implementation detail of how to run your native code inside JavaScript engine. And that is what WebAssembly is all about. It's not a language. And how it works, it's a structured stack machine. So you call a function called as add, and then it creates a stack for you. And inside that stack, you put in all the operands. You push all the operands. And once you've done the operands, you call in an i32.add, which is like do an add operation. And what it does is like it takes out all those things and creates a sum and returns a value. That's how WebAssembly works. It's nothing conceptually. It's just a stack machine. And the binary that we are generating is size and load time efficient, which means the binaries are smaller in size. And when it becomes smaller, it is much more easier to transport to the browser or to any Node.js environment, which makes it much more faster to load. And also, size is pretty much efficient because you're compiling and optimizing the code. But what does WebAssembly provide? It provides speed, right? This is the one that we are looking for, and it provides speed. And what kind of speed does it provide? It provides a near-native performance. And traditionally, any JavaScript work and any WebAssembly work, if you put it together, you might get almost 30% faster than JavaScript execution speed. And that is very huge. JavaScript is really fast. I mean, really, really fast. And the amount of work V8 engine people or the JavaScript engine people are putting to the JavaScript engine, it is awesomely fast. But you get more performance with the help of WebAssembly. And that is something really cool. And of course, WebAssembly works similar to JavaScript, which means it is working on a similar sandbox secure environment. And if you're working on the web side, actually, it also uses the same origin. You can script block it. You can do all sort of things that you can do with JavaScript. So that is really cool because it's secure too. And it uses linear memory model. What is a linear memory model? Anybody? OK, I just don't have time for the questions. OK, so linear memory model is a contiguous array. You put all the elements together next to each other. And that memory model is very good for adding information to it because it's much more faster. You know the endpoint, and you just put information inside it. And also, for selecting a particular location and getting a value out of the location is also much more faster. But updating and deleting some information inside it is much slower, and that is a problem with linear memory model. And WebAssembly extensively uses it, which means you have a memory that is shared between your JavaScript and your WebAssembly runtime, and this memory is used to put information inside. But if you're deleting information, you should not use WebAssembly. You should think about your solution. And how this memory array looks like, it's nothing but a shared array buffer. Is that the yellow line shows here? OK, so that's the yellow line, which means like it is good and bad. Good in the sense it gives you high performance. Bad in the sense the Spectre and the security vulnerabilities because of Spectre and Meltdown reduces the speed in which you can allocate stuff with shared array buffer. And that is a bad thing that happened. But overall, the main problem that we had with JavaScript, which is typing information, WebAssembly gives you type. And everything is statically typed, which means like you have two runtimes that are running. One is WebAssembly, the other one is JavaScript, and both lives inside your JavaScript engine, which means you don't need to download an extra runtime there. And you can share only numbers between them. 8, 16, 32, 64, any bit, but just numbers can be shared between them. So you have to share something like string. You have to share some objects. I mean, we work with objects and strings, right? We are experienced developers, right? Not just numbers. So how we are going to do it? For example, if you want to pass a string between JavaScript and WebAssembly, all you have to do is like put that string inside the shared memory, and then take the pointer where you put the string and the length of the string, and you just give the pointer and the length to the other world. And the other world takes information from the shared memory. That's how it works. It's very simple. But the boundary crossing that we have seen so far, like moving from one runtime to other runtime, it is bad. I mean, it adds overhead to your performance. So when you're designing a solution for WebAssembly, think about it. How many times does it have to cross the boundaries? If that is going to cross multiple times, don't use it. Just use your JavaScript because JavaScript is fast. But on the other hand, if the number of crossings between the runtime of JavaScript and WebAssembly is smaller, then just use WebAssembly. And it is not always faster. You have to agree to it. It is not always faster. If you're accessing DOM, if you're doing something else, which WebAssembly is not made for, it is not faster. It is much slower than JavaScript. So think wisely before you use the WebAssembly stuff. But how does it work inside the browser? You load your WebAssembly, you just call a fetch on the WASM file, and after that, you create an array buffer. The array buffer are nothing but bytes. Once you have these bytes, you instantiate those bytes. That's it. Once you have instantiated, you have this module within which all the functions that you're exporting, all the functions that you're importing, all the memories, everything lives inside that module. And once the browser receives that module, what it does is like it decodes it, and then it compiles it, and then executes it. That's pretty simple. So this is the JavaScript execution, and that is the WASM execution. WASM is much more smaller, and JavaScript is like 5, but it can be 7 or 15 or 18 steps, but WebAssembly execution is always 3. That is the fast. There is the performance that you are getting. And decoding is much faster than compared with parsing, because parsing is much slower. Decoding is very, very fast than compared with parsing. And the compilation that is going to happen is also much faster, because the code that you're generating is already compiled and optimized. And other benefit of using WebAssembly is like it also adds a streaming compilation for you, which means like when the first byte arrives at your browser or to your JavaScript engine in particular, when the first byte comes in, it compiles it, and then it makes it ready for execution. Because this is a compiled code, and it's much more easier for the browsers or the JavaScript engine to use that information and put it as in an executable state, which means like as and when it comes, you can execute them. So what languages can do WASM now? C and C++. It's a primitive thing. You can use tools like mscripten for doing WebAssembly, converting C and C++ code into WebAssembly. And if you really love dangling pointers and you want to enjoy pointer manipulation, you can use C and C++ with mscripten. And it's as simple as that. Is that visible? OK, it's as simple as that. You just write your normal C code, and then put in WASM export as an annotation on top of it, and run the simple code like emcc, which is the M script compiler. It creates WASM modules from the C and C++ file. That's it. But why do you have to go for C and C++? You have a ton of options. All the new features that are added into WebAssembly will be first released to the M script compiler, which is a compiler that we are using for converting C and C++ into WebAssembly modules. And it includes everything that you want to have it. The problem is C and C++ languages are not built for web, which means you have to have a trade-off of adding a lot of verbose information to make it run on the front end. And that is a huge pain that you have to go through. On the other hand, we have Rust. Rust is thread and memory safety. Any Rust programmers here? OK, one. Yay. OK. So it is less verbose than C and C++. The runtime is really, really small. So you need not worry about 10 megabytes of runtime or 5 megabytes of runtime. It's very small. And the language itself is built for running WebAssembly, which means like everything is inbuilt. What you have to do for running a Rust project is nothing but you run cargo install. Cargo is something like Node Modules package manager, but in the Rust world, you install a package or a crate, and we call it in Rust world. And then you say this thing, which is simple function that adds to integer, and then you build a WASM with that. Why have to go for Rust? It's inbuilt in the compiler. Everything is built on the compiler. All batteries are included, and it has an awesome tooling support. And sometimes it creates a bigger binaries. And if you're worried about size of the modules that you're generating, think twice before going to Rust. And you have assembly script. Assembly script, any TypeScript developers here? OK, few. TypeScript developers will really love assembly script. It's much closer to what they do. And it's as simple as that. You install an NPM module, which is assembly script. You create a TypeScript file, just give an extra type definitions. And you have limited type definition here because the WASM module can only support numbers. So you have to think that. And it generates everything. So you just have an assembly script compiler, which is ASC, and then run it. So you can also give an option like -O3 if you're doing C or C++. O3 is like optimization flag, and you can do that optimization over here itself. Why you have to use assembly script? Like it's closer to JavaScript community, and it has an awesome tooling. And the community is also really good, and if you have any new features, they can add to it. And of course, you have Go. Let me just quickly skip through this slide. Great. What is the future of WebAssembly? The very good thing that is happening, consider a world in which like you have a lot of different objects or a lot of different types or data structures that you want to pass between multiple languages. And you have you cannot do that now, but if you have a mechanism to do that, it would be awesome, right? And that is what interface types is all about. Like you write your program in C or C++ or Rust or Go or assembly script, anything, and then you pass that object between those languages using WebAssembly module. And that is what interface types is all about. And if this is a proposal that's on stage 3, and if that proposal is going to be true, it's going to be released, it's going to be live, then it would be really awesome for the WebAssembly, not only for the WebAssembly community, but it would be really awesome for anyone who's developing multiple languages together. Because you can use a particular language for that particular thing. And that is a great thing if it happens. And the next thing is single instruction multiple data. Anybody heard about SIMD? Few? No? OK. SIMD is single instruction multiple data. Consider that you have a huge array. You split that array into multiple small segments, do operations on those small segments in concurrent fashion, and then add some of all those smaller operations, add them together, which means you split, like, if you have an array of 1,000 integers, if you want to add them together, like, one by one, then you have to do 1,000 operations. With SIMD, you split them into 4 chunks each, which means, like, you do it in 250 operations. And that gives you a huge performance boost. And current CPU architectures are made for doing parallel processing or concurrent processing, and SIMD will actually help you. This means in the web world, in your browser, you can run SIMD and increase your performance. And this is something really great if it comes. And you have this garbage collection. And garbage collection is basically, we don't have any garbage collection. in the WebAssembly execution. Everything is handled by the application that you're writing. And we have generators for that. The generators take care of handling all the memory and management and all those things. But if garbage collection is natively added into WebAssembly, just like how your JavaScript works, then it increases the performance, one. And also, it also helps you to plug and play different garbage collections that you want. And it also opens the door for languages like Java or Kotlin or any other language to effectively come inside WebAssembly's execution. And finally, you have something like WASI, which is WebAssembly System Interface. And this is basically running in the Node. It's a replacement for Node.js you can consider. It's like running multiple languages, but in your browser. You provide a runtime, but in your desktop, in your machine. And it is built on top of POSIX. POSIX calls. Everybody familiar with POSIX calls, right? Anybody using POSIX calls? Nobody? OK. So JavaScript with WebAssembly together makes web better and even more awesome and faster. And that is the future that we are going together. WebAssembly is not here to kill the JavaScript or kill that entire community. WebAssembly will live symbiotically with JavaScript, and they both serve the web to make it even more awesome and faster. And thanks. Any questions, you can ask me. You have my Twitter handle over there. I've written a couple of blog posts on Dev2, and you can also follow me over there. And if you have any questions, I'm free, and you can ask me. That's it. Thank you.